Hey everyone. Today we're going to go through how to calculate a covariance matrix and, what is a covariance matrix. So first, before we start off with, what's a covariance matrix, we'll start off with what is a covariance. So covariance is basically how much x, like the variables in x, how similar those are to a different variable, for instance, y. So let's say we had a chart right here, and this is, x, and we'll call this y, and we have some points. So here you can see as x goes up, so as it goes in this direction, y also, goes up in this direction. So x goes up, so that was there. This one went up too because it was farther on the x-axis. So this is what we say, with this relationship, we say this has positive correlation. So that means, covariance. So the covariance would be greater than 0. If we had another example where the dots look like this, that would mean the covariance between x and y would be less than 0 because as y goes up, x goes down. Vice versa. As x goes up, y goes down. And then you could say something has 0 covariance if it's just random points and there's no real trend, or no real linear trend. So the goal of this is, today is how do we compute the covariance, and then how do we compute, how does that transfer to a covariance matrix? And now that you understand, a brief idea of what the covariance does and what's measuring, we'll go into some examples. So, theoretically, a covariance matrix looks like this. So it's the covariance of x comma x. It's covariance of x comma y. I know this is a little confusing. We'll go over it in more detail shortly. This is y comma x. And this is y comma y. So this would be a covariance matrix, but let's, also have a regular matrix so we understand it a little more. Let's say we had a matrix called A, or better than that, let's say we had a data frame with x and y. We'll say that equals 1, 2, 3, and this is 3, 2, 1. So, first off, we would want to figure out what, covariance of x comma x is. And we could look up here and look at the formula. So it'd be the sum over n of xi minus x hat times yi minus y hat all over n minus 1. Let's see if I got that correct. Yeah, so that's pretty correct. So in this example, the first one, the covariance of x comma x, would actually simplify down into the variance, but we'll go through that, just a quick example of why that would be. So let's say we would first let's compute this, and then we'll compute the covariance of x comma y. This way you see how to do both. So first we need the mean of x, which in this case would be 2. And we would take every value of x. So we would take x1, which is 1, minus 2, times 1 minus 2. So that would be the first instance. So we would take this value and subtract it from the mean of x. Then we would add that to now we do the same thing with the second instance. So it'd be 2 minus 2 times 2 minus 2 plus, and the same exact thing with the number 3. So it's 3 minus 2 times 3 minus 2. And we take all of that over n minus 1. So this is 1, 2, 3. So in our case, n equals 3. So n minus 1 is 2. 2. And that would give us the variance. or the covariance between x and x, which is the same thing as the variance. So we'll say this is cov underscore 1 equals this. So in our covariance matrix, we would have cov underscore 1. And that would be the first value. And this would theoretically be the same thing as the variance of x. Which makes sense because it's basically saying, as x goes up, x also goes up. It's comparing x and x, which is the variance. Now let's move on to the next example where we have the covariance of x and y. This one's a little more interesting and a little more, because it's the actual covariance versus just the variance. So here we would need first the mean of these numbers, and then the mean of these numbers. In our case, the mean of x equals 2, and the mean of y equals 2. And we would take each value, so we'll do it like this. We'll say x1 minus, the mean times y1 minus the mean of y. And then we'd continue doing this for all the values in our data set. So this would be x2 minus x prime times y2 minus y with the hat on top, and so on and so forth. I don't really have enough room to show the rest of it, but you do that one more time with basically these numbers right here. And then, so we know n equals 3, so we could put a 2 down here. And that would give us the covariance if we actually plugged in all those numbers. So we'll say this equals cov underscore 2. Cov underscore 2. One thing to note about this matrix we're creating is it's symmetric, meaning that this value is going to be the same exact thing as this value. So this would be covariance of 2. And this value, cov of, we'll call it 4, which is equivalent to the variance of y, because this is the covariance of y comma y. I hope this, helped out and made the process a little more understandable. If you want to try programming this, you could go to my website in the description below. It's called DeepMLeet, and you could try out this problem and other problems like it. Have a nice day, guys.